code data from the basin stratigraphy, which tells informs us about the paleohydrology, the water the conditions of the water that was present when the deposits were laid down.
Yeah. All right.
There we go. Okay. I'm gonna hand it over. I'm worn out. I want to just a couple things about logistics. So, our lunch stop today is going to be at between stop 2 and stop 3. We're going to try to get back to the vehicles and move them from stop 2 to stop 3, and that's a pretty good lunch spot. Time, if time goes pretty well, we're going to try to keep this introduction stop a little bit short, and then we're going to do a traverse out to these the brown and gray knobs or hills that are in the middle ground there. So Mayor's going to say a few things about the previous work and some of the burning questions that all of us have had down here in the basin. Matt's going to talk about the structure at the south end of the basin. And no, that way. This is the basin over here, or it's a paleo basin actually, because it's not a basin anymore. But anyway, the Spur Hills, and then Dan's going to say a few words about the stratigraphy.
I don't know. I don't know if I need to see it. I can't see any stratigraphy from here very well. So
yeah, we're not going to let him talk about the stratigraphy until he can see some, I guess. But then we'll after Mayor's presentation, we'll probably just do the traverse from there, and she'll set that up.
Why don't you do the structure thing? Background.
you gotta give me a minute here.
I'm not going to hold this megaphone for you, though.
Give it to me. Okay, so lots of people have done a lot of work in this basin over the decades. Lots of people have done a lot of work in this basin over the decades. And I just want to run through that real quickly so you know, but if you look at the picture that's on the front page of your guidebook, that's some of them. And one of them is here today, and two of them actually, counting me. Marty Mifflin's here, over there. Wave your hand, Marty. Marty did a lot of work with Roger Morrison here when Roger was kind of getting old. And anyway, let me go back to the beginning. So Shepard and Good were USGS geologists who came out to the Tacoma Basin, and they were very interested in diagenesis and geochemistry, but they also recognized that there were 3 prominent volcanic ashes in this basin, which they named A, B, and C. And A was later identified by the next person who did a lot of work here, Jack Hillhouse, produced a geologic map of the basin deposits, worked on the paleomagnetic history recorded in those sediments. Ed Larson from the University of Colorado also did some of that. And Jack, along with Glenn Izett and Andrei Sarnowojcicki, worked on identifying those volcanic ashes. And it's now well known that A is the Lava Creek, 640,000 years old. B is the Bishop Ash, 760 out of Long Valley Caldera. And C, you're going to hear a lot about on this trip, but at one place in the basin where it was relatively high and not sitting in the diagenetic soup for very long, they were able to use blast chemistry to identify that the C tuff was the Huckleberry Ridge ash bed from Yellowstone at 2.1 million. Now, then those tuffs were traced around the basin, and it's relatively easy to do that with the Lava Creek and the Bishop. They stand out. They're young enough that they weren't so altered in many places in near-shore settings or basin margin settings, so that you can pretty well trace them and recognize them. That's not true for Tuff C, and we'll talk more about that later. Roger Morrison then did the first comprehensive stratigraphy, trying to infer a lake history, and I I have no idea where that's reprinted in the guidebook, but it's in there somewhere, I think. And if not, it's on this poster I've got here. And he believed that there was a small lake at about 2 million years ago, post-Huckleberry. There was not much going on in the millennia, or the, whatever they are, thousands of years following that, until getting up in time towards deposition of the Bishop Ash. And he recognized that there was a high lake at Lava Creek time, and following that, he had a lot of up and down lake levels that he believed ended at a high stand of about 543 meters, and he thought that that was early isotope stage 6 in age. Then the next person, and he revised these things, that was based on a volcanic ash that he thought was in a shoreline deposit. I think all three of us agree that it's not a shoreline deposit, and it's in a kind of a spring discharge groundwater setting, so it does not define a shoreline. It may be close to a couple 100,000 years old, but it doesn't tell you how high the lake was. Then the next person, really the next major person to come along is Dan here, who wanted to revisit all of the diagenetic alteration in the sediments and really dive into the stratigraphy and do it in more detail than had been previously done. And he's got a tremendous number of measured sections around the basin, most of which have been published. He's still got students working here, and we're going to see some of that new work tomorrow on stop 4. And a few years back in 2000, I came on a field trip here, the last one that Roger Morrison ever led. Was a GSA trip, and there were a few amazing people on that trip that are no longer with us, and Roger's one of them. There's a nice memorial for him in the guidebook. It was written by Marty Mifflin, came out in the QG&G newsletter. And also, just this spring, Rick Forrester, who worked a lot on Yucca Mountain and was the real ostracode expert for the western fluvial lakes and groundwater discharge systems, also died abruptly. So we're sad that he's not here, and Jordan is in here filling his shoes, doing a great job. So when I went on that field trip, I had a lot of questions about a lot of Roger's interpretations. Several of us had a lot of questions and didn't really understand why he saw things the way he did in some places. Then a few years later, I got started on a paleoclimate project working with Dave Miller in the Mannix Basin, and since it was not very far away, I thought, well, I'll just take a look at Tecopa too, and see if I can, do some other things that might help define the lake history here a little bit better. And at about the same time, John Caskey started coming up here to get out of the heat in southern Death Valley, and laying around under various palm trees and stuff, began to wonder what was going on here as well, especially since he was seeing, the end result of the Amargosa River coming into Death Valley and relationships to young tectonics down there and so forth. So that's how it all led to where we are now. And I was able to enlist Jordan in helping to identify the volcanic acids, the ostracodes in various samples to try to interpret the hydrochemical setting and physical setting, whether it's spring deposits and so forth. And what? Paleo environment, that's it, whether they're lakes and the chemistry of those waters. So, big picture, what we're going to be talking about during this trip is some revisions to the chronology that have to do with this tough sea problem, and Gary will be talking about that mainly tomorrow. We are going to talk about the differences of interpretation amongst Roger Morrison's publication, Dan's work with the detailed sedimentology, and our perspective from hunting for and finding beach gravels that we interpret as fairly accurate recorders of lake level, and the ostracodes, which tell us something about whether there was a lake or not and what chemistry that lake water was. So it tells us, for instance, it gives us a perspective on when the Amargosa River actually was contributing to water in this basin, because it has much different chemistry than the local groundwater. And we will also relate that to when the Amargosa River might have gotten integrated and exited this basin and went down into the southern Death Valley. I think that's all I wanted to say.